Assalamualaikum students, hope you are all good. So after the completion of exercise 10.1, today we are going to start exercise 10.2. Okay, so let's see what's the theorem in the exercise 10.2. So theorem number 1, prove that a quadrilateral is a parallelogram if its opposite angles are congruent. Okay, what is theorem 1? Prove that a quadrilateral is a parallelogram if its opposite angles are congruent. So we have to prove that a quadrilateral is a parallelogram if opposite angles are congruent. Okay, you know already about congruent, triangle, and parallelogram. Okay, so let's start with its proof. So first we have make the diagram. Okay, diagram. This is our quadrilateral. In quadrilateral, these opposite sides are equal. Okay, these opposite sides are congruent. Congruent, it means they are same in shape and equal in size. Okay, you can see that these two lines are same in shape. These two lines are straight. Okay, and also these two lines are straight, and these two lines are equal in size. Okay, if this line is of 2 centimeter, then this line will also be of 2 centimeter. So we can say that the two lines are congruent. Okay, so in this theorem we have to prove that the quadrilateral which have opposite angles congruent, opposite angles equal, then it will be a parallelogram. Okay, so first of all we have to write the given things that are in theorem. Okay, so given, what is given? ABCD is a quadrilateral. Okay, what ABCD is a quadrilateral? It means ABCD. This shape, this diagram is of quadrilateral with opposite angles equal. Opposite angles equal, because in theorem they are saying that opposite angles are congruent. So when the opposite angles are congruent, it means they will be equal. Okay, they will be equal. It means angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4. Okay, what we are saying, if opposite angles are equal, then the opposite angle 1, 2, 3, 4. So angle 1 will be equal to angle 3 because angle 3 is the opposite angle of angle 1. Okay, and similarly angle 2 is congruent to angle 4 because the opposite angle of 2 is 4. Okay, so these are opposite to each other and these two angles are opposite to each other. Okay, so we have to prove ABCD is a parallelogram. Okay, again I am going to repeat this. If a quadrilateral has opposite triangles, opposite angles, or its angles are congruent, then it will be parallelogram. Okay, so here are the proof, here are the statements and reasons. In quadrilateral ABCD, okay, we have 4 angles, angle 1, angle 2, angle 3, angle 4. So the sum of the 4 angles is equal 360. You know, in the triangle the summation of 3 angles, because in triangles there are 3 angles, so the triangle's total angle is 180. Okay, so similarly here the quadrilateral's total angle is 360. So the sum of angle 1, angle 2, angle 3 and angle 4 is equal 360. Okay, reason is here by angle sum property of quadrilateral. Okay, so we can say that angle 3 is equal angle 1, angle 4 is equal angle 2. Why? Because we have already said that in the given things that angle 1 is congruent to angle 4 and angle 2 is congruent to 4. Okay, because this is given in the theorem. that angle 1 is opposite to angle 3, angle 2 is opposite to angle 4. Okay, these are the opposite and congruent. It means these are the equal angles. So we have put there angle 1 same plus angle 2 plus angle 3 is equal angle 1. Okay, and angle 4 is equal angle 2. So this will be equal to 360 again. So what is the sum of this one? Angle 1 plus angle 2, it will be 2 angle 1. Angle 2 plus angle 2, it will be again 2 angle 2. So we have take the common 2 and write these angles in the bracket. So this will be again equal to 360. Okay, now this 2 will becomes in the division of 360. So angle 1 plus angle 2 is equal 360 upon 2. Okay, so angle 1 plus angle 2 is equal 180. We have read the table of 2 and simplified this. So the summation of angle 1 and angle 2 is equal 360, because the reason is these are the supplementary angles. Okay, which angles? Supplementary angles. So similarly we can prove that angle 1 plus angle 4 is equal 180. So for lines AD and BC, with AB is transversal, the lines AD and BC, okay, with AB is transversal. You know about transversal line, I have told you about that. The line that cuts two parallel lines, the line that cut two parallel lines and break the angles. Okay, so this is our transversal line. It cuts two parallel lines, okay, and break the angles. So AB is our transversal line. So for lines AB and DC with AD as transversal, this is the reason. Again, angle 1 and angle 2 are interior angles on the same side of transversal, and summation of angle 1 plus angle 2 is equal 180. Okay, in this statement we are saying that angle 1 and angle 2 are interior angles on the same side of transversal. Okay, I have told that A to B, this line is our transversal line. Okay, so angle 1 and angle 2 are interior angles in this quadrilateral diagram. Okay, so their sum will be is equal 180, because the reason is angle 1 and angle 2 are interior angles on the same side of transversal, and angle 1 plus angle 4 is equal 180 again. Okay, so now further statements are, since interior angles on same side of a transversal are supplementary, okay, then we are saying that in quadrilateral interior angles of the same side in the transversals are supplementary. You know about the angles that are equal to 180. Okay, so reason is here, since interior angles on same sides of transversal are supplementary, hence it is proved that AD is parallel to BC. Okay, and the reason is similar because AB is parallel to DC. Okay, so thus in quadrilateral ABCD, both pairs of opposite sides are parallel. Okay, both pairs of opposite sides are parallel. So it means a triangle ABCD is a quadrilateral ABCD is a parallelogram. Okay, it is proved that in the quadrilateral, if its opposite sides are congruent, it means same in shape and equal in size, then it will be a parallelogram. Okay students, so after the theorem 1 of exercise 10.2, now we will do theorem 2. Okay, so what is theorem 2? Prove that a quadrilateral is a parallelogram if its diagonals bisect each other. Okay, prove that a quadrilateral is a parallelogram if its diagonals bisect each other. Okay, so here is this theorem. Proof of theorem 2. I have made already the diagram of quadrilateral. Okay, diagram of quadrilateral. Here is our corners A, B, C, D. Okay, in this theorem we have to prove that Quadrilateral, this quadrilateral will be parallelogram, okay, if its diagonals bisect each other. Okay, what are the diagonals? The diagonal is a line that cuts two lines from the mid and breaks the angle. Okay, so the line from A to C, the line from A to C is diagonal line. Okay, and also the line from B to D is a second diagonal line. So in the theorem they are saying that the two diagonals intersect each other at a point, okay, then this quadrilateral will be a parallelogram. Okay, so we have to write the given things. Given in quadrilateral ABCD, diagonal AC and BD bisect each other at O. Okay, they are saying that in quadrilateral ABCD, diagonal A to C and diagonal BD, B to D bisect each other at O. It means these two lines cut each other. Which point? At point O. Okay, is that AO is congruent to CO. AO is congruent to CO. Okay, and BO is congruent to DO. Okay, so to prove that ABCD is a parallelogram, we have to prove that ABCD will be a parallelogram. So here are the statement and reasons. In triangle AOB, triangle COD, here is the comparison between two triangles. Okay, this arrow, this sign indicates the comparison between two things. Okay, so in triangle AOB and triangle COD, triangle AOB and triangle COD, okay, we are comparing these two triangles. Okay, these two triangles. So number one, statement number one, AO is congruent to CO. Yes, obviously, because this is given. AO is congruent to CO. Okay, congruent means AO, the line A to O will be equal to CO. Okay, this will be equal line and also same in shape. So these two lines are congruent and this is given. Okay. Number two, angle 1 is congruent to angle 2. Yes, we can say that because angle 1, angle 2, these are congruent angles because these are the vertical angles. Okay, these are the vertical angle. It means the point, this is the midpoint. If we join these two angles at some line, so these two will be equal. Okay, so the third point is BO is congruent to DO. This is also given. They are saying that BO is congruent to DO or OB is congruent to OD. Yes, obviously this will be again equal because this is a one line. Okay, and we have break this line from the mid. Okay, so obviously BO will be equal to DO and this is again given. So here is proof that triangle OAB, okay, will be equal to triangle COD. So this is proved by SAS postulate. SAS will be congruent to SAS postulate. Okay, so point 3, angle 3 is congruent to angle 4. Again, angle 3 is congruent to angle 4 because these are the same in shape, equal in size. Okay, so angle will be also equal by congruency of triangle S. Our fourth point is AB is parallel to CD. Yes, because alternative angle as 3 and 4 are. Okay, so we are saying that AB is parallel to CD. Okay, you can also see that these two lines are in same shape and same size, so this will be also equal. Okay, our fifth point is similarly AD is parallel to BC. Yeah, we can say that AD is parallel to CB or AD is parallel to BC. This is again parallel. Okay, So similarly, AD is parallel to BC by the above process are 6 points. This is the proof point that therefore ABCD is a parallelogram. Reason is opposite sides are parallel. Okay, so in this diagram we have seen that these two lines are opposite. These two lines are also opposite, equal and same in shape. Okay, and we also see that these two angles are equal, and we compare these two triangles AOB, triangle COD. So in this in this diagram we have proved all the sides that are equal and opposite and also same in shape, and also angles are equal. So this is proof that if the diagonals bisect at point O bisect each other, then this quadrilateral will be a parallelogram. Okay. So after the theorem 2, okay, now we are going to doing theorem 4. Okay, this theorem will be your homework, so you have to do at home in theorem number 3. Okay, so what is theorem number 4? If a quadrilateral is a parallelogram, it has diagonals which form two congruent triangles. Okay, if a quadrilateral is a parallelogram, it has diagonals which forms two congruent triangles. Okay, so let's start the proof. So here is theorem 4. I have made this quadrilateral. Okay, so A, B, C, D are its corners, are its vertex points. Okay, so in this theorem, the theorem is saying that if a quadrilateral is a parallelogram, okay, it has diagonals which form two congruent triangles. Okay, diagonals means the line is going from A to C. Okay, the line which cuts the two parallel lines. Okay, so in this theorem we are saying that the diagonal A to C form two congruent triangles. Okay, so congruent triangles, it means the triangle ABC, this is our first triangle, and triangle ADC, this is our second triangle. So these two triangles will be equal. Okay, so we have to write the given things. Given is ABCD is a parallelogram. Okay, this is given in theorem 1 that ABCD is a parallelogram. To prove triangle ABC is congruent to triangle ADC, this is again given in the theorem that we have to prove two triangles are congruent. So what is the construction? Construction is diagonal A to C divides the parallelogram into two triangles, triangle ABC and triangle ADC. The diagonal A to C divides this parallelogram into two equal triangles. Okay, so here is the proof, statement and reasons. Parallelogram ABCD. In parallelogram ABCD, first of all we will see the whole diagram. Okay, so number 1, AB is congruent to CD. Yes, AB is congruent to CD. It means the line A to B is equal to line C to D. Okay, reason is ABCD is a parallelogram, and you know about that in parallelogram all the two opposite sides are equal. Okay, second point is AC is congruent to AC, because this is a common side. Yes, we can say that AC is congruent to AC, because when we will divide these two triangles, AC, okay, AC line is same for this triangle and A to C line is same for this triangle. So we can say that A to C is our common side. Okay, so point third is AD is congruent to BC. Yes, we can see that here AD is congruent to CB. It means AD is parallel to CB. So reason is ABCD is again a parallelogram. Okay, So from these three things, this is proof that triangle ABC is congruent to triangle ADC, because by SS postulates. Okay, what is SS postulates? When three sides are equal, okay, then two triangles will also be congruent. Okay, and we have seen that these two lines are parallel. The line DCAB are also parallel, and AC is also equal and same. So when three things, these opposite sides are same in shape and equal in size, then this is proved that this quadrilateral is a parallelogram. Okay, and this is again proof that